Assalamualaikum and hi everyone. So kali ni kita tengok chapter 14 Thermodynamics. Okay, what is the thermodynamics? The study of relationship involving heat, mechanical work and other aspect of energy. Okay, so heat kita ada Q, work kita ada W, and energy kita ada U. Okay, U ataupun E. Alright, so first one kita tengok dulu the first law of thermodynamics. Kita ada Q, which is heat, is equal to delta U is internal energy plus W, which is work done. Okay, what is first law say? First law of thermodynamics say that the heat Q supplied to a system is equal to the increase in internal energy of the system and the work done by the system to its surroundings. So in mathematics or in equation we have Q is equal to delta U plus W. Q is quantity of heat supplied, W is work done, delta U is the change in internal energy. Okay, remember that the U, delta U, is only depends on temperature. Okay, where delta U is equal to F over 2 nRT. Okay, so the internal energy depends only on temperature of the system. If the initial and final temperature is the final temperature of the system is the same, so delta U is equal to 0. Okay, because there are no change in temperature. No change in temperature. So, bila no change in temperature, so our delta U equal to 0. The change in the internal energy is also 0 in the cyclic thermodynamic process or repeated process, because initial and final state of the system is the same. Remember that the internal energy do not depend on the volume. It only depends on the temperature. Okay, so this is the sign convention for heat and work. Okay, so kita tahu Q is positive when the heat is supplied. Q is negative when the heat is released. So dalam soalan akan bagi tahu either the heat is supplied or heat is released. For the sign convention for work done is positive value when the work is done by the system. Ingat, work is done by the system. Kalau negative value, dia cakap work is done on the system. Okay, work is done on the system. Okay, kita tengok contoh soalan. Example number 1. 2495 joule of heat. Okay, so this one is Q. Is used to heating a mole of neon gas. A mole N equal to 1 of neon gas. Neon gas is monoatomic gas. Okay, from 27 degrees Celsius to 147 degrees Celsius at constant pressure. Okay, determine the change in internal energy. So the change in internal energy we have delta U equal to U2 minus U1. Remember that delta U is equal to F over 2 nRT. So T temperature, temperature yang ke final minus temperature pertama lah. Okay, so we'll have the okay, so we have the solution here. Okay, we have delta U is equal to F over 2 nR T2 minus T1. So F, since the neon is monoatomic gas, so F equal to 3. Okay, so F equal to 3 tu, so kita dapat ni 1498. So remember, ini mesti dalam Kelvin. Okay, nombor 2 nak cari apa? The work done of the gas. Okay, the work done of the gas by we apply the first law of thermodynamics. We have Q is equal to delta U plus W. So kita calculate, kita akan dapat 999 joules. Okay, seterusnya kita ada 14.2, which is the thermodynamic process. Remember, kita ada 4 proses. First is isobaric process. Isobaric process is pressure. Okay, pressure remains constant. It's known as isobaric process. Then kita ada isochoric. Isochoric ni nama lain dia adalah isovolumetric. Okay, ini kita ada volume remains constant. And then we have adiabatic process. Adiabatic process ni Q equal to 0. Okay, so macam mana kita kira work done? Kita just kira Q sama dengan delta U plus W. So Q kosong, so equal to delta U plus W. So delta U is equal to negative W. Okay, so kat sini ada berarti proses no heat transfer. Okay, involved is called adiabatic process. And then we have isothermal process. Isothermal process ni adalah proses di mana temperature remains constant. Okay, we go one by one. Okay, isothermal process is defines the process that occurs at constant temperature. Okay, occurs at constant temperature. Okay, so for the isothermal process, when the gas expand or compress, so remember that delta U equal to 0 because the temperature constant. Okay, when temperature is constant, so delta U 0 because there are no change in temperature. Okay, so we have Q equal to W because delta U equal to 0. So PV is constant here. Okay. Seterusnya kita dapatkan pula work done in isothermal process. Okay, so untuk work done in isothermal process, remember that okay, ni dia punya integration sajalah. So tak perlu nak ingat semuanya pun. Kita just ingat W sama dengan nRT ln V2 over V1. Okay, V2 over V1. Ataupun kita ada, seperti kita ada V1 over V1 sama dengan V2 over V2. So V2 over V1 equal to silap sikit. Silap sikit. Mari. Kita ada kita punya segitiga dengan PVT. So P1 V1 equal to P2 V2. So P1 over P2 equal to V2 over V1. That's why kita ada Q ataupun kita ada W, which is work done is equal to nRT ln V2 over V1, or we can have W equal to nRT ln V1 over V2. Depends on the question given. Okay, this one is for isochoric or isovolumetric, that process that occur at constant volume. Okay, so kalau constant volume, ingat, so constant volume kan, delta V kosong. Okay, delta V kosong, so W equal to 0. W equal to 0. So, kita ada kat sini W kosong. W kosong, so Q sama dengan delta U. In an isochoric process, all energy is added as the heat remains in the same as it increases, and the internal energy, thus the temperature is increases. Okay. For example, kita tengok heating of the gas in the constant volume. Container is an isochoric process. Ingat, isochoric process is the process occurs at constant volume. So bila constant volume, kita punya delta V 0. So bila delta V 0, work done is also 0. Then kita ada isobaric process. Isobaric process is the process that occurs at constant pressure. So bila constant pressure, so kita ada W equal to P delta V. Okay, so ni kita punya proses kita. Okay, kita tengok satu-satu. Work done. Okay, yang ni untuk work done untuk isobaric ya. Where W equal to P delta V. So ingat kat sini kita ada beberapa proses. Okay, kita ada beberapa proses kat sini. Saya insert slide dulu. Okay, kita ada proses isobaric P delta V. Isochoric dan sama dengan kosong. Isothermal dan sama dengan nRT yang kita over V1 ataupun nRT long V1 over V2. Dan untuk adiabati kita ada Q sama kosong, so Q sama dengan plus W, so delta U sama dengan W or vice versa. Okay, kita tengok lagi. This is the pressure volume graph. Alright, so proses ET4. Okay, dia semakin tinggi tu semakin tinggi dia punya penamanya tu suhu dia. Okay, suhu. So proses A kepada P is isothermal process, di mana suhu, okay, suhu at B bila di line ni, okay, semua suhu ni sama. Okay, line ini pun sama, suhu yang sama. So TB sama dengan TA. TA dengan TB is in the same line, so TA sama dengan TB. Untuk proses AC is the adiabatic process. Okay, di mana TC is lower than TA. TAC is less than TLA. And then we have isochoric process. Process A to D is isochoric. So bila isochoric, kosong volume, work done kita kosong. Okay, and then we have AE is isobaric process, di mana lagi tinggi, okay, lagi tinggi di ke atas suhu dia tu semakin tinggi. So macam kata yang ni 100 degree Celsius, macam kata yang ni 55 degree Celsius, yang ni 20 degree Celsius. Okay, ataupun Kelvin pun boleh, tak ada masalah. Okay.